Thanks for taking the time to join this evening's session, or this afternoon session as it is, depending on where you are in the world. We're going to be covering and having a look at some of the multi-site always-on, so when I say always-on, failover clustering and availability groups, some design considerations around implementing multi-site type environments. Okay, so if we move on, just a quick bit about me. I'm a sales engineer here at SQL Sentry. Joined them in August of last year. Prior to that, I was a Premier Field Engineer for Microsoft here in the UK. Over 10 years experience with SQL in one form or another as a DBA, SQL dev, BI developer, that type of thing. Down the bottom left there, my contact details. Feel free to drop me an email, tweet me. I do blog occasionally as well up on SQL Sentry blogs. So what I'll do is I'll get all the slide decks and any code as well. I'll get that put up onto my SQL Sentry blog, and I'll give John the links for that as well. So not a problem. It'll be there to find if you want to get hold of this stuff. Okay. Quick thing as well. Okay, we're giving away a Plan Explorer Pro license to everyone who fills in the feedback, but we also have ebooks that are normally $10 each. If you go to our website, you can download them, but if you go to send an email to ebooks@sqlsentry.com, say that you sort of sat through my session, which session it was, and they'll give you a code and you can get them for free. So they're proper content, a couple of hundred pages, people like Aaron, SQL Skills team, putting proper technical content together. So it's not just marketing guff. If you are interested in SQL Server monitoring tools, that's what we do at SQL Sentry. 4 main tools there. If you want an online demo with me, there's the link, and that's the end of the selling. So, into the content. One of the things that, just to sort of clarify before we go much further into it, is just about what is always on. Okay, you'll see a lot of blogs, content and such like online, people saying always on, and then talking about certain settings and things like that. The most important thing to understand is that always on is actually the set of features. Alan Hurt has done a blog post recently that helps explain how the terminology has changed over time, with the marketing department changing it, and I believe the latest incarnation of always on has a space between the two words, and again still relates to a set of features and such like. So those features are failover cluster instances that we all know and love, and availability groups, introduced with SQL Server 2012 and progressing through 14 into 16. Mainly Enterprise Edition at the moment, but with 2016 that should hopefully change, although the scope of that capability that's coming with 16, not entirely sure on yet. So when I say always on, I'm going to be talking about both features. If I'm talking about one particular feature, I'll make reference to FCIs or availability groups. Okay, so we start talking about availability groups. Some of the really important things we need to understand about availability groups, first and foremost, they're database level protection. Okay, means that one or more databases on an instance will be replicated to a number of other replicas. Depending on which version you're using, the number of secondary replicas will vary, that you can have the maximums of. But essentially, it's database level scope. Okay, and they are, whilst you can put a number of databases together into an availability group, essentially the unit is that database, and you just move a whole pile of them that are in that group together to one of the other replicas. Okay. Storage is local. When I say local storage, I don't mean it has to be physically plugged into the server. It's essentially it's dedicated storage to that particular server that you're going to be running the SQL Server instance on. Now, when we look at this one, that can be SAN-based. It can be PCI Express Flash, it can be spinning disk, you name it. SMB file shares. If it's virtualized servers we're looking at, then obviously VMTKs or VHDXs and such like as well. Okay, but the main thing to look at is it's presented directly to the server. The reason being, when we look at having our multiple replicas, there's multiple replicas of that database. So if you've got 5 databases that total 500 gigabytes in size, that means you need 500 gigs worth of storage space at least on each and every server to manage that. Okay, so it does have a larger storage footprint. And we'll discuss some of the storage considerations when it comes to looking at implementing these solutions as we go forwards. Then we have our failover cluster instances. This is instance level protection. Okay, so whereas before you're looking at a database level scope, we're looking now at an instance level scope. Very, very useful when it comes to the synchronization of things like jobs, logins, and so on and so forth. We don't have to do them. Shared storage. So you've got a number of cluster nodes that can potentially run the instance. So whereas under availability groups you've got 4 or 5 instances, maybe this one you've got a single instance that can run on a number of physical servers or virtual servers, depending on how you've got your cluster set up. Okay, so that's typically configured in such a way that one node will own that and it will be active on that node at that point in time. And there's a single replica of the database, so the storage footprint is typically smaller. With regards to multi-site configurations, then obviously you're going to have multiple instances of the data, and we'll explain a bit more about that in a minute. But essentially, there's a much smaller storage footprint if you're looking at failover cluster instances, even on a multi-site environment, because you've just got less instances of the database. But it's important to understand, obviously, if you get corruption in that database, then you've got a lot more impact potentially if you're having data issues. Okay, so multi-site. Why do we look at multiple sites? We're looking for improved resilience. Now, if everything's in one room in a building can burn down. Not a great scenario, but you don't want all of your eggs in one basket, really. Multi-site scenarios mean that you can have pretty warm versions of the system standing by, ready to come online as you need them. Okay, now makes life a little bit easier than having to say go to tape and then bring some servers online on a second site and restore the databases and so on and so forth. Okay, building that in from the get-go, very, very important. If you can do it, it's great. Improving high availability and disaster recovery solutions and scenarios, really. And one of the things we talk about is you've got high availability and you've got disaster recovery, and it's very, very important to understand that they're two clear, separate entities. Okay, so high availability is not always disaster recovery, and disaster recovery is not high availability. We look at the versatility and flexibility of multi-site environments as well. So there's a customer I worked with a while ago. They had a data center in one location that was prone to hurricanes and another data center in an area that wasn't prone to hurricanes. And given the weather, they could actually get a couple of days worth of notice that something was coming. Using something like availability groups meant they could spin down the applications, flip it to a synchronous replica, transfer everything geographically from one zone to another within their architecture, bring everything back online and start transacting the business. The hurricane goes through. If there's any damage, then their ability to work is not impacted. We also then need to think about our recovery point objectives and recovery time objectives. The requirements that these drive will have an impact on how you set up your environment. So again, if you're looking at a multi-site system, what is the recovery point objective? Can you make sure you get all the data in a consistent state to the secondary site in such a way that when you have to bring it online, you meet those requirements? Again, can you bring it online in such a timely way that it will meet those requirements? So again, thinking about that and understanding the technologies that you're going to need to use in order to implement that is going to be very, very important. Okay, so that's some of the reasons why we might look at a multi-site environment. Now, before we start going down that road, it's very, very important to understand what are you looking for? Multi-site high availability or multi-site disaster recovery? Okay. Now, I've worked with a number of customers, and quite often you'll be speaking to the business or senior people, and they'll say, yeah, when this one goes down, we want that to automatically come online on the second site, our disaster recovery site. Well, automatically doesn't tend to sit well with disaster recovery. If it's going to be automatic, it's typically high availability. If it requires some manual intervention, is bigger than just a small component in the system, then you're typically looking at disaster recovery. Okay. Now, understanding this and documenting it effectively, your best bet is to, in my experience, get clear definitions: high availability, disaster recovery. Okay, and then you can apply them and say, okay, well, which one do you want? Okay, that will help you guide the system you're going to design and build, and it also helps set the business expectations for the systems that you're going to be running, so they don't expect too much in the event that you have to fail everything over to a second data center, because typically the data platform section is a component in the larger enterprise. Okay, so bringing that online, you need to make sure you've potentially got applications need to be repointed and so on and so forth. Okay, so before we start jumping into some of the more some considerations we're going to look at, has anybody got any questions? Have we got any questions so far? So, doesn't appear so. Okay, so we'll continue on. Looking at some of our considerations, some of the key ones that we want to understand is our storage layout. Okay, now as I said, with availability groups, we're looking at what is effectively local storage to the machine that we're running the availability group on. Okay, so we've got 5 servers, we've got 5 storage subsystems, we've got 5 sets of storage. Okay, that makes life a lot easier when it comes to synchronizing storage and the databases between the systems, be they on the same site, be they on the same physical site but different rooms in the same building. So for example, you've got a large campus and you've got a computer room or data center at each end, synchronizing between those. And then you've got to look at the ones that potentially you're going from one geographic location to another. So south of England to north of England, maybe think Iowa, North Carolina, things like that. You want to understand what are the considerations, how much bandwidth have we got, what storage platforms are we going to be using. Okay. If you think about failover cluster instances, they're not going to handle the replication of data. You're going to need to start looking at third-party solution. So is that going to be SAN vendor? Do you need to get the SAN team involved, all that sort of stuff? Okay, and how do you make sure you're synchronizing all the volumes appropriately so you don't end up with transaction logs and data files out of synchronization for a database? Okay, there are other software solutions, things like SIOS have got a great solution as well that works very, very well. Okay, otherwise, availability groups, they handle the synchronization quite happily through the transaction log blocks that they're sending between the replicas. Then we think about our network connectivity. Okay, now there's a number of elements that we want to look at here. Primary among these is going to be our latency. Latency is going to be the thing that potentially hurts us the most in a multi-site configuration. If you've got to go, for example, London to New York, transatlantic, or say London to Houston or Dallas, then you're only going to be able to get data from that location, from London to East Coast or Central sort of America in a certain time. Okay, the laws of physics dictate that you can only send it a certain speed. Okay, you're not going to get it in sort of sub-millisecond. Okay, just not going to be possible. So understanding the latency between your sites, very, very important. Again, this is really just not from the data synchronization perspective, but also from some of the clustering configuration environment. So understanding the latency between the nodes. Okay, so that's going to have a bearing on how prone they are to failing over, how sort of reliable is that network as well. So if you're going from one location to another, is it a very, very sort of reliable network connection? If it's not a reliable network connection, then you need to potentially look at modifying some of the configuration settings that we have in clustering and such like to make it a little bit more resilient to some of these intermittent dropouts. Okay. We need to think about our versions of software and use as well. Now, with regards to the operating systems, we're going to be looking at Windows Server, obviously, because we're running SQL Server. Now, if you want to run or are running some of the older operating systems, 2008, 2008 R2, there are going to be specific KB fixes that you're going to need to put in place in order to handle potentially multi-site environments. Okay. From a SQL Server perspective, multi-subnet environments, so multi-site has been possible on sort of 2008 R2, but required specific network infrastructure configurations, such as a stretch VLAN. had to be the same network subnet on both sides. With 2012, the ability to have multiple subnets in use for clustering and availability groups became a possibility. Okay, so the same connectivity resource will have two IP addresses. One will be active, one won't be. Okay, so again, you've got to think about what you're using there. From a clustering perspective, we can do clustering in standard edition, limited to 2 nodes, but it is also limited to single subnet as well. So if you're going to be looking at this and you want multi-site and multi-subnet failover cluster instances, you're going to be looking at Enterprise Edition. Okay, so just bear that in mind as well. And we need to think about the client application design as well. Okay, with regards to the connection strings and the way that they connect to the data platform. Okay, there's a lot of off-the-shelf software, System Center, things like that. Okay, that don't support something known as multi-subnet failover. This is a connection string property that you can set. Okay, and it will impact the way that the application connects to the data platform. Where you've got these out-of-the-box products where you typically got a form of some form, a web form or a Win form that you put in a server name, put in a database name, and that's about the extent of the configuration options that you have. Then you need to look at configuring clustering appropriately, specifically around DNS and the IP addresses and such like that are put in place there. So what we have. So start off by looking at storage configuration for failover cluster instances. As I said, in this example, we've got 2 nodes, one on site A and one on site B. The failover cluster instance spans both nodes, so it can run on one or the other. Okay. Now, as we can see, on site A, we've got a SAN. On site B, we have a SAN. And we're synchronizing data, typically at the block level, using the storage subsystem. Okay. Now, it's very, very important if you start looking at this configuration to work closely with your SAN admins. If you don't speak with them properly and you say, can you just synchronize these volumes, they may set the synchronization up, but they may not synchronize them in the right way. Essentially, what you want to make sure they're doing is grouping the transaction log, or the LUNs that effectively hold the transaction log, and the data files. You want them grouped together so they're synchronizing in parallel, so they remain in sync as well. Otherwise, you can end up with transaction logs and data files that aren't in sync, which means when you try to bring them online on the secondary site, it doesn't work. Okay, I've been there with a customer when they basically set all the groups up wrong in their SAN, so they were synchronizing all of their transaction log LUNs as a unit, and then synchronizing all of their database LUNs as a unit. So there was a bit of a mismatch between the databases and the transaction log files when they started to try and bring things online. Okay, so just bear that in mind. Like I say, typically you're using a SAN-based solution. If you've got failover cluster instances and you want to do it in the cloud or whatever, then you're looking at third-party software solutions such as SIOS solution. Well worth having a look at if that's the route you want to go down, just because of the limitations around shared storage in the cloud. Okay. So again, we need to think about what's the connectivity medium, what's the latency involved, are we running synchronous, are we running asynchronous? If we're running asynchronous, are we preserving write orders, things like that. Okay, so again, the SAN guys, the storage guys typically know this. Well worth having a look at and having a good chat with them. Take them out for a beer, get them on side. Life makes it a lot easier. Okay. Whereas if we look at the availability groups, again, we talked about local storage earlier. We've got here 5 nodes. We've got 5 SQL Server instances. We've got the availability group that spans those 5 instances. And we've got individual replicas of the database. Okay, so node 1 could be synchronizing synchronously to node 2. Node 3 and 4 and 5 could all be asynchronous copies, be them on the same site or other sites. Okay, so it's more of a logical entity here. The Windows Server failover cluster as well that sits underneath this and coordinates who's primary and such like, and bringing resources online, offline. Again, setting that up and making sure that the configuration is appropriate so you don't end up with a large amount of latency between the nodes causing spurious failovers, things like that. something you need to understand, something you need to look at, and some of the configurations you need to work with. Okay, so we'll just check again before we move on to the next section. Have we got any questions at all in the window, or are we all good to go?
No, I think we're good to go. We had a couple about the recordings and the material, which I've been able to answer.
Okay, no, that's great. It's not a problem. So, okay, without further ado, we'll jump on and we'll start talking about network connectivity again.
Oh, actually, one just came in. If you wanted to talk about it,
Yeah.
question was if you could discuss the licensing impact with high availability and disaster recovery.
Oh, that's the one question I really didn't want to get. Licensing, it depends. I think at the moment,
so I know in standard you can have a 2-node cluster, right? And
yeah.
in 2016, there's going to be new functionality where you can have an availability group of a single database.
Yeah, so you've got the basic availability groups coming from a licensing perspective. The number of licenses that you need to purchase for your SQL Server instances. It's going to depend. If you're a large organization with an existing EA contract, then you're going to have to go and speak to the licensing people, see what's in that contract. If you're buying brand new, then you're going to have to look at getting software assurance. Last time I read the licensing documents, in order to get the passive node for free, and typically then well, I say passive node, the one that you're not conducting live business activity on, if you will. So if you've got an availability group with 2 servers, to have the one sat there as the hot standby ready to take over, then you'd have to buy the license for the primary and have software assurance as well. That's as I read the documents, and that was probably about 2 or 3 months ago. May have changed since then. If you want to have more replicas, then you will need to look at purchasing more licenses as well. So the more replicas you have, the more licenses you'll need to purchase. And obviously, if you're going to be doing a virtualized platform, and this is where someone like David can really help, understanding if you're licensing at the host level for SQL Server, a lot of those headaches can go away. Okay, so availability groups in the context of virtual systems can be very, very good, so long as you design your storage platform properly, so you don't end up with 10 hosts all with the same availability group underneath it on the same SAN storage, and the SAN falls over, then that's gonna mess with your high availability solution anyway. So, sorry, I can't give you a more definitive answer than that. Like I say, Microsoft changed their licensing so often, and it's not the clearest thing in the world. And there's so many different contracts and based around what you've had in the past and what state those contracts are in, that anything I say could be quite wrong. Okay, so moving on and looking at network connectivity. As I mentioned earlier, latency is one of the key things that can hurt you. It can hurt you in a number of ways, and we'll discuss those shortly. Multiple IP subnets as well. This is going to be an interesting one, especially with regards to the way your applications connect, making sure that they can connect appropriately. Are they multi-subnet aware? Have you got access to the latest connection strings and the libraries in order to make it happen? So if you're running with things like .NET 2, .NET 3, that type of thing, you may not necessarily have the required multi-subnet failover connection string properties. So if you're using 3.5, 4 and stuff like that, you should be fine. There are ways that you can actually go back to use the old mirroring style connection strings, but again, if you've got more than 2 IP subnets, then that's all going to break and fall over anyway. So if you can use the latest .NET connection libraries and so on and so forth, it will make your life a lot easier. Okay. The clustering network config as well. So we've got our standard. We give it this IP address, so 192.168.10.10 in subnet 1 and 192.168.11.10 in subnet 2. One of the things I do tend to do where I've got multiple subnets is try to have the same final sort of octet for my IP address on both sides, because I can only think so much, and if it's the same on both sides, it means I've got to think slightly less and it makes it easier. Okay. But then we look at our network clustering config, and we're talking about things like subnet delay. So essentially, there's two features, well, not features, parameters that you can set for clustering networking properties. One is around essentially how often the communication between nodes takes place and how many of those communication heartbeats can actually be missed before it will start basically going through the recovery phase of failing things over if it has to. Okay. Got that in a little demo later on, and we'll have a look at it. But essentially, this is where you'd set up that resiliency to transient network issues. Now, one thing to understand when we look at that around the network connectivity side of things as well is that if you are using a stretch VLAN, so you've only got, so this is where you have multiple sites but a single IP subnet. If the distance involved is such that you have to start looking at that, then you need to look at the same subnet delay and thresholds. Now, that can be a little bit more complex because you'll have local nodes and remote nodes, and they'll all fall under the same parameters and the configuration as well. But we'll have a look at that in a bit. So, dealing with latency. This is going to be a very rudimentary example, but we have two sites, two servers with our transaction logs. So we have our update statement come in on our primary. As we start writing to the transaction log, we'd start writing our transaction log blocks. They're going to get synchronized. Now, availability groups are built effectively on top of the old mirroring technology. Mirroring used to send things, it'd send the remote part, then do the local one. Here, availability groups are sending them in parallel. So they're sending the log blocks to the remote side as well as actually hardening the transaction log locally at the same time. So you can see we're doing this action, and you can see we're already a couple of steps behind where we want to be on our local one. So once the log block has reached the second site, it then gets hardened in the transaction log on the primary, yep, hardened, come back as well. So then we go through, yep, it's been hardened in the transaction log, and then we send the acknowledgement back. Okay. Now, if this is synchronous, we have to wait before we can commit the transaction and send the information back to the client application and say, yep, we're all done. Asynchronous, there's some other things that we need to think about. Okay, so looking at this high-level architecture, what we have here essentially is we've got local latency, which we're all well and familiar with. So we're looking at network latency. So how many milliseconds are we taking to do writes into the transaction log? What's our write log weights? Things like that. Okay, and then we have what the term here is remote latency, if you will, the remote portion of it. This is the bit where we're sending to the other node. That other node is hardening it in its transaction log, then sending the acknowledgements back to us. Now, in an asynchronous environment, what this can have an impact on effectively is your log send queue. If you've got a high latency, you've only got a certain number of threads that are able to synchronize the data, and that send queue can build up on your primary. The impact that has is going to be on your recovery point objective. How much data has actually managed to reach that async secondary? How far behind is it? How much is sat there waiting to be sent still? Okay, so whilst it may not necessarily impact the performance of your queries, your inserts, your updates, your deletes, and things like that that are reliant on writing the transaction log, it can have that impact on your recovery point objective. Okay, so understanding that and monitoring your log send queue again is going to be very, very important. Okay, now the way I tend to view this is the transmission to the secondary site, the whole process from sending it from the, in this instance, from site 1 to site 2, hardening in the transaction log, and then sending the acknowledgement back, I just treat it or think about it as a logical extension of the I/O channel. Okay, so I've got disk latency on my system that I'm dealing with here. It's my local latency. My remote latency is effectively an extension of that. If I've got slow transaction log on my primary site, it's the same sort of things if I've got a slow transaction log and a slow send and high latency between my primary and my secondary. It can have an impact. That impact will depend on whether it's synchronous, asynchronous. Okay. Now, one of the things we did briefly touched on there was if, for example, we have that secondary running in synchronous, so we wanted high availability, multi-site high availability. So we've configured them synchronous. They're auto failover partners. When I hit that commit, the bit that's going to be really causing us a problem is our remote latency. In this scenario, I've got to wait. So even if I've done my local commit in 4 milliseconds, okay, nice and quick, but it's going to sit there. It's going to wait now until I've hardened that record in the far transaction log. Okay, it doesn't have to be replayed into the database, but it has to be hardened in the transaction log. Now, if it takes 4 milliseconds each way between the two servers anyway, then I'm also looking at the I/O latency on the other end as well. That's going to be an overhead that's going to be introduced into my application performance. So understand how long it takes to complete the remote commit portion. Okay, so again, thinking about that. Now, briefly touching again on multi-site high availability disaster recovery scenarios. Multi-site high availability, we need synchronous between both sides. They need to be consistent, so zero data loss. Now, zero data loss is an interesting concept. It depends on whether you are an IT person or an end user, really. Zero data loss, again, comes down to, are we running synchronous? Have we got the transaction logs there and they can replay and bring us back to the same point in time? Technically, we haven't lost anything, apart from what was in flight and hadn't been committed. Sometimes, though, if you're looking at users and you say there is zero data loss to users, they will consider data loss from the point that as soon as they hit go in their application. Okay, so understand that, and you need to look at potentially architecting your applications in a way to handle these failovers as well. So if we've got that synchronous one, we can deal with that. Okay. From a disaster recovery perspective, obviously if it's running asynchronous, we can have a portion of data potentially lost that's sat in the primary that's not reached the secondary. Again, that's understanding what's in your log send queue, what hasn't left yet, how much data are we there, how far behind are we. So if you're doing maintenance operations, if you haven't got a sort of blackout window where you've got nothing coming into the system, if you run a big reindexing operation and you're also still taking inbound transactions and you get them all mixed up in there, what's going to be the impact? Okay, are you going to end up sat behind a whole pile of stuff that needs to be sent for the reindexing, and you've got the user transactions in there as well? Again, that can really inflate the latency and the disparity between the primary and secondary sites. Okay, so just understand that and how it's going to impact the maintenance operations you normally do. Okay. Now, we've talked briefly about the multiple IP addresses and things like that as well. I'm going to have a quick look at a demo. Before we jump into that, I was just wondering if we got any more questions at all?
No, we don't. So if anyone has any questions, please make sure you throw them in the queue here so we get John to give you some good feedback on them.
Not a problem. So what we're going to do is we're going to have a quick look at this. We're going to look at a couple of things. Okay, so give me a second to find my VM. DB1.
Well, I'll tell you what, while you're doing that, John, I'll throw a question while you're loading that I think people probably should be thinking about. How do you monitor and know if you're having network latency issues?
There's a number of different ways you can do it. Obviously, the way I start off with the most basic way is I would just start pinging from between the servers. So when I'm starting my planning and I'm starting to commission things, what's my latency? Understand that. If you've got network management teams, then they can normally got monitoring tools or such like. They can provide more insight to the actual network infrastructure, understanding the latencies between site A, site B. If it's going to be a hybrid solution as well, you've potentially got the cloud. Also, Tim Radney recently put a post up for us on the SQL Sentry blog sites about mapping your network latency as well with various tools. So that's well worth having a look of a read there, and I'll include the link to that in the slide deck so people have got that to hand.
Cool. And I've actually got a blog post for next week. I actually just implemented this at a customer site. We've got extreme network latency between the application server and the database server, and we actually initiated pings within SQL Server and tracking this in a table just to get more data points on it. So I'll have that blog post next week.
So yeah, there's a lot of different ways you can do it, and it depends on what you've got available to you. Like I say, planning stages, it can be something as rudimentary as pinging between the nodes. I'd ping every node from every node, start getting averages, that type of thing. If you've got monitoring tools that can do that, great. So well worth having a look at. Now, I'll quickly look at this. I've got a very basic availability group configuration here in my Windows failover cluster as well. So if I zoom in, you can see here I've got my cluster. Now in my cluster I've got my cluster name. I've got 2 IP addresses. So I've got 2 IP subnets here. I've got 192.168.10 and 192.168.11. Okay. Now the important thing to understand when we look at a multi-site configuration like this with multiple subnets is that we've got to have an OR dependency between our IPs. Obviously, subnet 11 IP address cannot be online whilst we're sat on subnet 10, like vice versa. Basically, if you're on subnet 10, IP address 11 can't be online. So seeing something offline is perfectly normal in this scenario. Okay. So beyond that, I've got 3 nodes. Quite happy here. And then I've got no shared storage. Just sat here, it's all local. Okay. Now, the configurations we want to look at, we saw we had 2 IP addresses. So what does that mean? Now, we saw one was online, we saw one that was offline. So if I just grab this VM, if I look here in DNS, what that means is I've got 2 listeners, one for each availability group. Okay. Super close up. Now, as you can see here, so my listener for AG1, I've got both IP addresses in DNS, and likewise for AG2, again, both IP addresses in DNS. Okay, so one of the things you can have here is applications that aren't aware of or able to handle effectively multiple IP addresses for the same host record. You can try doing connectivity and you might get the right IP address, you might get the wrong IP address. If you get the one that's offline, you're not going to get connectivity. So you'll get ping timeouts, for example, your application saying, nope, can't find the database server, things like that. Okay. Now, this is where our multi-subnet failover flag comes into it, really. So if you go to Management Studio, and I'll just do a quick connection here. So if I go to lab G01, okay, we connect in there, okay, quite happily. So I've managed to get the right IP address, which is nice. But one thing we can do, if I just disconnect that, there it is. If I come to options as well, additional connection parameters, net failover equals true. So one of the things we want to look at, this is the connection string flag. So if you've got a .NET connection string, you add this. Obviously, if you're using Management Studio, you can add that here as well. And then if you're having issues connecting through a multi-IP address environment, you can do that. And what that means is the connection drivers will basically go and retrieve all the IP addresses and attempt a connection in parallel to them. Once it establishes connection, it effectively disposes of the ones that it hasn't yet connected to. So it's a bit quicker than the old mirroring one where it would try them in sequence. Okay. So if we've got an application, for example, say System Center, calling it out on this one, it can't handle multiple subnet environments, but you want to run that, then there is a way that we can actually say, I only want to register a single IP address. Okay, so got broken out the PowerShell here. So what I'm doing is say, this is my cluster group, and it's the network name that I want to change these properties on. And we've got effectively a true or false flag on the network name saying register all IP addresses or register only the active one. So I'm going to say, right, I don't want to register both. Now, what is very, very important is to make sure you've got the TTL quite low, the time to live. Now, essentially what this means is when I give it DNS my host, when I've got a host name, I go to DNS, I resolve it to an IP address, and then I effectively cache that locally. Default 20 minutes. Now, in the event of this where you're registering only the active IP address, you make that change in DNS very, very quickly. But what happens is the clients that have cached that will not go back to DNS until that time to live value has expired. So if you've got it there for 20 minutes, you're potentially looking at impacting your failover and your application connectivity for 20 minutes. Bringing it down to here to 30 seconds means that after 30 seconds, clients will go back to DNS, pull information down and say, okay, what is this host name to resolve to? Okay. So what I'm going to do is I'm going to go to clustering, and I'm going to tell clustering to say, when you register the IP address, register it with a time to live of 30 seconds, okay? Because if you don't set it here, it will use the default up in DNS, okay? So what we're going to do here is we're going to set the register all providers IP address parameter. So nice bit of PowerShell here, get the cluster name, feed it into the cluster group, get the specific resource, and then we're just going to set that particular value. Okay. Come down here. Okay, so then we just set the time to live as well. Now to make it effective, we have got to turn it off and on. So turn that off. Turn this back on. This is where the demo guard, that's working, that's fine. So now if I come back to my DNS, what we should see if I refresh this is that now we've only got the single IP address actually in use and available in DNS for us. So again, where we've not got that ability to set the multi-subnet failover equals true setting in the connection string for our applications, we can say, all right, I only want one IP address resident in DNS, so that every time the application comes in, that's what's going to be returned. Okay, so that's how you get around a multi-subnet scenario where you've got multiple IP addresses and the inability to resolve them in parallel. Now, the other thing we talked about was cross-subnet delay. Okay, now this is essentially setting things up so if we've got transient network failures or we've got high latencies and things like that, we can adjust it. Now, if I come down to here and we'll have a look at our current settings, okay, the default here is 1 second and 5 missed heartbeats. Okay, so this is essentially how often the heartbeat's going to be sent. This is how many of them we can miss before the cluster's going to think about doing a failover for us. Okay, now cross-subnet delay, this is where we're dealing with a multiple site scenario where we've got 2 distinct IP address ranges. And what we're saying is that communication between the nodes that's crossing subnets, we want to increase the amount of latency that we're going to allow before we have a failover. So the min and max values there are we can have a minimum of 1/4 of a second, maximum of 4 seconds. We can have anywhere between 2 and 120 failed heartbeats. Okay. Now the network failure tolerance, the time that you can have between failed connectivity between network nodes, is going to be a calculation based on turn that into seconds and then how many missed heartbeats, so how many seconds can we have a look at. So the default one, if I set those up, what we can say there is that we've got a default of the nodes not being able to talk to each other across the subnet for 5 seconds. So I might want to increase that and say I'm happy to have 10 and I'll send them every 2 seconds, okay, which then gives us a network resiliency effectively of 20 seconds between the nodes not being able to talk to one another. Okay, so what we can do there is, what I'll do is I'll just pull the cluster information out here and I can set that and then come down the bottom and we can see that talking between nodes on different IP subnets that we might have on different sites, we're going to send every 2 seconds and we're going to miss 10. But for the nodes that are local to each, so the nodes communicating between each other on site A and then the nodes communicating between each other on site B, they'll be dealing with a threshold of basically we send one every 1 second and we can miss 5. So you get that variability. Like I say, if you've got a multi-site environment where you have one single IP address subnet, then you need to look at setting the thresholds for the same subnet threshold, but bear in mind that then that's going to apply globally across both sites. Okay, so just bear that one in mind. Okay. Any questions about anything we've covered here at all?
We got one in flight here, but I'm trying to get a little more info on it to target it better for you, John. No,
No, that's fine.
This is great stuff, and this is all stuff I've had to implement in the real world. I mean, I have a way of pulling errors, and I worked with a client before that had over 300 failures due to basically networking and this exact issue where changing these settings instantly helped with the issue.
It makes life a lot easier. I mean, one of the most important things to understand from a network perspective is that the weakest point in your configuration is going to be your comms link between site A and site B. There's nothing to say that someone takes a big dig, a JCB, cat dig, or whatever, digs up the road, digs up your comms lines. It's going to make life difficult. Now, with regards to that, coming back to our slide deck.
All right, we have a few more questions if you still have a...
Yeah, let's go for it. Let's go for it.
I got a little more info on that persisting multi-subnet failover setting where they're interested in Management Studio and connection string. So just kind of wanted to see what would be the best way to persist those.
How do you mean, as in?
Well, I think for Management Studio, right, I'm pretty sure there isn't a way to persist that. But if you have a connection string, right, that's just a part of the connection string.
Yeah, you just write it as a connection string parameter. So if you've got your web.config or your app.config file where you're saying server name equals this, database name equals this, semicolon, multi-subnet failover equals true, then go from there, really. So that's what you need to look at doing. So in a connection strings, you write it and actually put it into the connection string. For Management Studio, sometimes it persists things in that window, sometimes it doesn't. I found it a bit hit and miss. But no, when it comes to your application connection strings, it's just another connection string property that you set. So you got your web.config, it's just another thing with the semicolon on it as you go through. So database, server, database, security, multi-subnet failover, yada, yada, yada.
Yep. And another good one, if TTL is reduced for DNS, does it impact database transaction time?
Not a database transaction time, no. What it will impact is your application resolving to connect to the database server. So every 30 seconds, it's got to make that trip back to DNS server to say, right, who does this host name resolve to from an IP perspective? So depending on how the applications are written, if they're opening and holding connections, then yeah, that's going to have limited. But if it's going to be opening and closing connections very, very rapidly, every 30 seconds, that machine's going to have to go and say, right, I need to go to the DNS, I need to cache that information again. So it can introduce a lot more work for the DNS servers, depending on the numbers of connections, the number of servers you've got that are making those requests. So if you've got 300 web servers and one DNS server, that DNS server could get basically 300 servers polling in every 30 seconds or so. So that's where you need to consider from the extra infrastructure side of things.
Great.
No problem. Is that it? Are we ready to?
Yep, we're all out there. So if anyone has more questions, we'll get them in at the next break.
So Quorum configuration. Let's see. Can you tell if I was a DBA or not? It depends. It really does depend on the architecture you're going from, and it comes back to what I said at the beginning. You want to understand, are you going for multi-site HA? Are you going for multi-site resiliency and disaster recovery? If you're going for multi-site HA, then obviously the nodes that you've configured for either the failover cluster instance or the availability group that are going to be the automatic failover pairs or anything that it can automatically fail over to are going to need to have votes in the quorum. Okay, so that's going to be important to understand. Taking votes away, in Windows Server 2008 on R2, you've got to add hotfixes to be able to adjust node weight effectively. I would really caution against anybody using those older operating systems for pretty much anything these days as a rule of thumb, just from a life cycle perspective. But also, in 2012, the dynamic quorum capability came in, where the clustering subsystem has the ability to help, say, basically at its most fundamental level, calculates whether or not a node should have a vote given the number of nodes that are active in the cluster and are able to vote, basically trying to maintain a number of votes in order to maintain quorum in the event of a failure. Okay. Can be useful, can be a pain, depending on your configuration, the number of nodes, the way you've got them set up. Likewise, in 2012 R2 operating system, you get the dynamic witness capability where the witness will surrender its vote or take a vote, in addition to having the dynamic quorum capability as well. I'm still a big fan of getting my hands dirty and setting this. So where you're dealing with potentially a multi-site disaster recovery scenario where you're doing an asynchronous transfer to the secondary site, which means you're going to have to do a forced failover anyway, take the votes away from those nodes. Because obviously if someone comes along and digs up the road and digs your comms lines up, you really don't want to be in a position where that site could be up and running, but tries to, for whatever reason, try to come online if you've got them configured wrong, or takes down the cluster because you've got potentially more nodes, more than 50% of your nodes outside of your primary site, that sort of thing. Okay, now 2012 R2 operating system can, in most cases, sustain 50% of the nodes failing at once, so long as the quorum witness, or sort of the witness for the cluster, is actually resident to the active portion, if you will. So you've got 50% of your nodes disappear, but you've got 50% plus the extra vote from the witness involved, means that it will stay up, typically. If you lose more than 50%, then even if you've got 2 or 3 nodes on your primary site that could still be functional, clustering will turn them off. So just be careful with that. Have a look at it. There is some very, very good guidance from Microsoft in their documentation on the main things you consider, which I've covered pretty much there. Just look at your scenario, look at your overall design. Is it multi-site HA or is it disaster recovery? That's going to have a big bearing on what you need to look at when it comes to setting your configuration for your quorum up. Okay. As I said briefly sort of earlier, we got software versions, 2008 operating system and above. I wouldn't use anything less than 2012 R2 just from a life cycle perspective. Most of the systems we put in place are going to be alive for a number of years, and I'd rather have a fully supported operating system, SQL Server combination, and not have to try and do an operating system upgrade underneath it, because when it comes to clustering, you're better off just building a new one and moving everything. SQL Server, Enterprise Edition 2012 and above. When it comes to 2016, we're going to have our basic availability groups, which appears to be the same scope or coverage, if you will, as mirroring capabilities. So at the moment, it's looking like no listener, single database, single replica, that type of thing. Okay, so just bear that in mind. What are the versions you're going to be using? But these are the minimum requirements. Okay. The application design side of things as well. We touched on briefly around making sure that the application is using the latest connection drivers, things like that. But really, we want to be allowing for latency. Are we going to allow, if we're doing multi-site synchronous replica, do we want to set it up in such a way that the application can handle some latency? Making use of caching tiers, things like that as well. Try to offset hitting things into the database as best we can. Queuing as well. So be it something like RabbitMQ or another queuing mechanism, so the applications write to the queues then write into the server, so you're making that whole process of getting data in and out of the database as asynchronous as you can to try and speed things up and minimize the impact of the overall latency to you. Then we need to think about unreliable connections. Depends on where your application servers are, depends on where your data platform's located. Think about how things are going to be working. If you've got an unreliable connection link, then we need to bump up the cross-subnet delay, same subnet delay if we're doing the stretch VLANs, that type of thing. But also building in, because it's a high available solution, and you've got availability groups and failover cluster instances have the same profile when they do a failover, be it single site, multi-site. They sever the connections to the client. So everything that's in flight at that moment and not committed in the database, not going to be logged, it's not going to be automatically restarted. This comes down to us understanding what classifies as data loss. Are we looking at it from a user perspective? They've put it into the form on the page and they've hit go. After that, well, I've just lost an hour's worth of work. That's typically what you hear from them, even though they've just, it's not actually committed into the database, things like that. In that scenario, understanding the architecture pattern for building retry logic in. Okay, try to connect to the database to do the work, can't connect, back off. Don't automatically go back to the client and to the end user effectively and say, nope, it broke. Give it another go. So back off for a second, try again. Back off for 2 seconds if you fail, then try again. If you fail for a third time potentially, just turn around and say, nope, can't do it, then go back. Especially if you've got things like potentially a hybrid cloud infrastructure, anything where you're involving the internet, it's an inherently unreliable connection medium. So if you've got your app servers on site, you've got a secondary replica up in Azure. Again, just you're going to be transiting the internet potentially. That's going to be a real pain unless you've got something like ExpressRoute in place. Okay. So these are all things we need to think about. And with that, have we got any more questions?
We do. Some are kind of related and some are but aren't. So I'm trying to kind of help flag some of those down as well. But we do have some more here, which is a great thing.
Yeah, that's cool.
So someone was just kind of wanting to know basically how an application would switch between the nodes if the node on which the application or the SQL Server database is running on fails.
Mm-hmm. So it depends. I mean, if you look at the latest version of NT Framework, which I know as database professionals is not something we're keen on doing, there's the ability in the connection libraries effectively to build in that logic at the application level. So in the event of a failover, obviously SQL Server is going to kill connections, and the application is going to get an error, basically connection terminated or you can't connect, depending on whether or not the system's up or down. Building that logic in, so it's very akin to deadlock retry logic that you may want to put into, say, you've got try catch logic in your stored procedures. So you look for the deadlock error number and you say, if I've got this, right, back off, go in, try again, back off for a second, try. So you're effectively looping it's a loop construct to say, try to connect, with a sort of back off in there as well. Give the system time to try and fail over. Then come back and fail. There's no real way of easily detecting where the primary is, short of building the application to look at all of the nodes and say, right, who's primary? Bit like the way the backup selection mechanism works. So you just query all and say, who's primary? Right, I'm going to then connect to you, which becomes a double connection process, which can introduce a lot more overhead. Does that make sense?
Yes, great. And I think here our last one here due to time.
That's right.
With having multiple IPs and a subnet, does the change of the IPs happen automatically, or does this have to be done manually?
No, the IP address change in DNS will happen automatically when the system fails over. Basically, the network name will register itself in DNS and say, this is my name, this is my IP address. But what you need to do is go into clustering and then configure, is it going to register both IP addresses or a single IP address every time it effectively goes offline and comes online?
Perfect. So with that, thank you, John, and everyone for attending. Once again, when you guys leave, there'll be a quick survey that pops up with a few questions that can help make this virtual chapter better for you, and then some questions that we were asked to help John make this session better for him as well. And we'll use that as our drawing for the SQL Century Pro license that will be given away.
So yeah, Plan Explorer Pro. So if you could fill the feedback in, obviously, if you thought I sucked, please tell me why so I can improve. If you thought it was great, thanks. But like I say, everyone who fills in that will go into the draw for a Plan Explorer Pro license, and we'll get that sent out.
All right, thanks everyone. We look forward to seeing you next month.
Thank you very much, everyone.